Hello and welcome. I'm Tom Palmer. Tonight we're speaking about the scientific worldview. With me is scientific philosopher Dr. Glenn Borchardt. Dr. Borchardt, thank you for coming.
Yeah, thanks for having me on.
So good to have you here.
Great.
So your book, The Scientific Worldview, tell me about it.
Well, the scientific worldview is not a popular title. This is the only one. And I was very curious early on, I think in about 1978, about this whole idea of the universe exploding out of nothing. And I said, that's strange. And so I really pursued it and tried to figure out, well, what's going on? Because this is not something I was normally doing in my own field. And so I was curious, and I looked into it and discovered that what is happening is that people are using assumptions that get them to the Big Bang Theory. It's one of their main assumptions in science is called finity. It means that there's a finite particle and that the universe is finite. And I was saying, well, what if I just did the opposite? And then I studied Collingwood. In 1940, he wrote a book, an essay on metaphysics. And in that book, he said, if there's any fundamental assumptions, the way to find them is to find their opposites, because fundamental assumptions always have opposites. Okay? So another thing you do when you look for assumptions, you have these opposites, and then you also must realize that if they're fundamental, you can't prove them. For example, in science, I already knew that, well, there are causes for all effects. But until we discover all the causes for every effect, we haven't proven it. So it's an assumption. It's kind of a faith, if you will. And so this is true. And so I looked for certain assumptions that religious people had, indeterminists, I call them in the book, and determinists, which I am. I say there are causes for all effects. That means there's no free will, because if there wasn't a cause for all our actions, that wouldn't make any sense in the way
Russell wrote about that.
Pardon?
Russell?
Talked about that?
Yeah.
I'm not really familiar with his very much. Many philosophers have tried to handle that in various ways. Spinoza was into determinism and so on. But that's what science really is, determinism. And so anyway, I looked up these various possibilities for assumptions. One is materialism. Materialism says that the universe is made out of matter. And that essentially what has happened is the universe is made out of matter, and the opposite is called immaterialism. That is, that spirit is more important, or that maybe it isn't made out of matter. And then they go on with causality. Like I was saying, you have causes for all effects, and there's some indeterminists who might say, well, there are some causes, there's some effects without causes. And so they go on and on. I have 10 assumptions that I started with. That's the basis of the book that I wrote. And what Collingwood said as well was that if you have more than one assumption, they have to be conseponable. Now that's a word that only a few people have used, Collingwood, W.H. Auden, and myself. And what conseponable means that if you can assume A, or number one, in order to assume number two, they can't be in contradiction. So one of the things about the scientific worldview, as I wrote it, is that one of the assumptions is infinity. It says, and this is the most important one, it says that the universe is microcosmically infinite and macrocosmically infinite. Now this, of course, comes up against the current theory, which is that the universe exploded out of nothing and it's finite. And so I use these as the basis of the entire philosophy, and went through the whole analysis. I came up with this idea of univironmental determinism, because I wasn't too happy with the way some determinists had spoken out. He'd say, one, for example, would be environmental determinism. What it says is that the environment determines what happens. And I thought, boy, it makes sense that it's really an interaction. So what univironment means that we are combining what I call the microcosm, that is a portion of the universe, with the macrocosm, which is the remainder of the universe. So univironmental determinism says this: whatever happens to a microcosm is determined by what the infinite matter that's inside of it and the infinite matter that's outside of it. And that's what unienvironmental determinism is, and that is what the scientific worldview is. Now, it turns out that the current scientific worldview is systems philosophy. And I've done this myself. What you do is you put a sphere around whatever you're studying, and you study only that, and you ignore everything outside of it.
Including the observer.
Right, and the problem is you can't do that. No system is isolated. In an infinite universe, it's very clear. What's been done now with the Big Bang Theory is that we are treating the entire universe as a system without an environment. And that's where unienvironmental, that's why I put the uni in there to emphasize that it's a unification of the two. And this is what essentially makes me in contradiction to the current Big Bang Theory. Now I realize that the Big Bang theorists are starting to get out of their little box, so to speak. They're now starting to talk about multiverses, parallel universes, and so on. They intuitively realize that you can't do this just the way they are doing as a systems. And
Can I ask, Dr. Borchardt, how do you account for the redshift in an infinite universe? This idea that, the way I understood it, that when we measure light from all sources entering our planet, it's shifting red, which indicates that the source is receding from us.
right, that is actually happening. You have a red, we call a red shift and a blue shift. They're called the Doppler effect.
The blue being something coming towards you.
When like Andromeda, for example, the galaxy is coming towards us.
Right.
And that happens. But of course, the redshift increases with distance from the Earth. And in our new book and in the paper that I just finished writing, I've further elaborated on this. And what I should really say, Steve Pitts, who was my co-author on the third book that we wrote, he is really a brilliant mathematician, and he has just come up with some amazing stuff. So we collaborated on this book called The Universal Cycle Theory. And in there, we've come up with the idea that what is really happening is that in the intergalactic regions, light actually travels at velocity higher than c. And because of that, it travels over a greater distance for the same number of cycles. You see how that makes a redshift? You automatically get a redshift. Now there's data on this. They call it the gravitational redshift. There was an experiment done by Pound and Rebka at Harvard, and they had a tower, and they shot some electromagnetic radiation up towards the top of the tower and then also down. They found a redshift going up and a blue shift going down. And now, of course, astronomers do find gravitational redshift all over the place. Every time you look at a big body. In fact, just the other day, they came out with yet another proof that this proves Einstein's right. See, and they use that his math and so on and his ideas to say that, well, this is another proof of Einstein. And actually, all it is a change in the velocity of light, essentially as it moves towards empty space, if you will. Now, our theory is an ether theory. What we claim is that light and gravitation are produced by ether. The pressure of ether is greatest farthest away from matter. Matter is made up of ether particles. In fact, matter is complex ether particles. So the density then of ether increases with distance from the Earth, for example. As the density increases, the velocity of light increases. And as light comes towards the Earth, it slows down.
So all this would contradict Einstein entirely.
Yeah, and there's some attacks now on him in regard to light really not being constant. And in our book, we point out that there are no constants. It's sort of like pi, 3.1416, da 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 da. There's no end to that. That's because the universe is infinite. And there are no constants. There's always a plus or minus in every single thing you do. If you don't have a plus or minus, do it again, more precisely, and you'll find you have plus or minus.
Do you feel in the reaction to your work that anything that rocks the foundation of our understanding of the physical world in an Einsteinian way is ignored or even attacked because it just really is too radical.
Well, that's always true with
Are we
every
penned
change.
in? Our
Yeah.
thinking is penned in.
Well, that's remember what we're talking about is a paradigm shift. Like Kuhn said in The Structure of Scientific Revolutions, the only way you can really make a big change a big paradigm, is to do it from outside. And so
People have their mental
yeah.
patterns. We were talking about George Lakoff and how these thought patterns are embodied and they have a physical structure, and
Right,
they're just
exactly.
not going to change so
and
quickly.
we all have that.
That's right.
Yeah, in your field, you have your definitions, your assumptions, and your vocabulary, all determined. See, your vocabulary determines what you can think. Once you have thought now of univironmental determinism, you're going to think about it. What does that mean? What happens to a thing or a portion of the universe is determined by what's inside of it and what's outside of it. So, Tom, what's going to happen to you is going to be determined on what's inside of you and what's outside of you. What's in your brain, what's in your body, everything. That is going to be, you're not going to be able to determine everything that happens to you. If you're driving down the road and it's a 2-lane highway and the guy wants to drive off your bumper, not much you can do about it, right? You could try to swerve out of the way. So that's the macrocosm. You're always dealing back and forth between the macrocosm and yourself. So that's very, very important. And once you think of that, instead of thinking in terms of systems, which are isolated, and there are no such things, then you have a completely different way of looking at things. And you're right, the paradigm that we're trying to change, it's silly, really. The universe exploding out of nothing. And it's really, really silly because when you make something, what do? You bring things together, right? What is the Big Bangers are suggesting that by coming apart, we're going to create a universe. It doesn't make sense. And so that's and of course, explosion out of nothing. Now, you can say, well, infinite universe is also very difficult to believe, and it's true.
Well, it's equally incomprehensible.
It is. We can't comprehend it.
Yes.
That's it just goes on and on. But you have a choice, that or explosion out of nothing.
Yes.
Which do you prefer? Indeterminists prefer the explosion out of nothing for various traditional reasons. But as a scientist, that doesn't turn me on at all. That's kind of where I started with this.
It's taken you far afield from soil science, which is your PhD.
Right.
Yeah.
Yes. Soils is really a good field because it involves so many different things.
Yes.
Chemistry, physics, anthropology, geology, of course. And so I really love soils, and that's what allowed me to do this. I never had a philosophy course. Even though I've got a PhD, you can get a PhD without any philosophy. And mostly it's the scientists I was working with said, well, that's kind of worthless. You know, it's hocus pocus, and we are not interested in doing any of that. And now I know why, because the philosophy that's available isn't very good.
Well, if you're going to have a cosmology, it would seem that you need philosophy also to comprehend it.
That's right. And see, what we have now is called a cosmogony or cosmogony. What it means is that it's this cosmogony is the study of the origin and ultimate disposition of the universe. It assumes that the universe had an origin. And of course, a finite universe would always have an origin, like anything finite. But in other words, we are doing cosmogony, we're not doing cosmology. Some people do. A lot of astronomers, they could care less whether there's a Big Bang or not. They're still studying various galaxies and stars and so on and doing just fine.
You are a presenter and a member of the National Philosophers Alliance?
It's the National Philosophy
Alliance.
Right.
Yes, thank you. Mm-hmm. Yeah. And this is a group of scientists and laymen who have similar...
Right. We call ourselves dissident physicists.
Yes.
Mostly we are opposed to the Big Bang Theory and to relativity.
Yes.
Not all of us are. And we
String theory?
Of course, anything more than 3 dimensions, we don't go for. There are some people, new people come in, they may come in with ideas of 4 dimensions and some kind of compromise with Einstein or whatever, or a compromise with the Big Bang. We have some people like that. It's a very open group. We allow almost every discussion of every topic. But it's limited. We have maybe a couple hundred members, and but it's growing, and we're getting quite a bit of action going. Each meeting is getting more populated and so on, and getting some good papers. I've had pretty good reception with some of my stuff, so been good.
Good. So what's the next step for it? I suppose you would want to get this really more into popular acceptance and
Well, that's interesting there that you'd ask that. One of the members of the organization has a movie that they're talking about. It's called Einstein Wrong, and it has a little bit of stuff from the NPA and some of the harebrained ideas of some of the people in the NPA, and some of the good ideas, of course. And it seems like it's really going to turn out really well. It's going to be a documentary form, and the idea, it's David DeHelster is the fellow who's doing it, and his idea is, well, this is one reason he's helping out the NPA a lot, is because he needs to have somewhere for people to go once they actually see the movie. Well, what do I do now? Can I get some more information?
Oh, right.
So, and so the Natural Philosophy Alliance is where to go.
It seems like Einstein is so central to our thinking, just to
It is.
It's hard to dismiss him.
Yeah. Well, I thought the paper I wrote last year was pretty much summed it up. It was called Einstein's Most Important Philosophical Error. And you might ask, well, what's that? What error would that be? The error was that he objectified motion. Now, the universe consists of matter, and the matter is in motion.
So motion's an action.
It's an action. It's not a
dimension.
Thing. It's not a thing.
It's not a,
it's not like I wave my hand. That's not a thing. My hand's the thing.
Yeah.
But the waving of my hand is not a thing.
Yeah.
So what he did is he made time, for example, he objectified it by having it another dimension. And we all do that. We say, well, I'm going to save some time for you. And people who think that time is a thing, because I'll ask people, what is time? Especially ask a modern physicist.
Well, you also learn that it's relative. Motion. You learn that all
motion is all relative.
Is,
right?
is that true then?
Yes. Universal time is the motion of everything with respect to everything else.
So all motion is relative to other motion.
It is. It is.
Well, that's Einsteinian.
That part, that he wasn't the first on that. He emphasized it. That's true.
Yeah.
So it's in an infinite universe, it's really important. So universal time is the motion of everything with respect to everything else. If you want to measure time, it's always going to have to be specific time. So you're going to measure, the revolution of the Earth. You're going to measure sand falling down an hourglass, a clock of any sort. Always involves motion. And motion is not a thing. And if you think it is, I always challenge the modern physicists by definition, a modern physicist won't know what time is. Because in order to be hired, you have to be a follower of Einstein. And so you won't know what time is. You won't know that time is motion. And I have a hard time convincing even my co-author, time is motion, time is motion.
Oh, interesting.
It's that ingrained. It's very, very difficult. And he's done other things. In regard to motion, light is motion. It's the wave motion in ether. Okay, if you deny ether, then what is it? Einstein said it's photons that travel at the speed of light. The photons, however, have to be massless. If they had any mass at all, they'd have infinite mass, and then that wouldn't work. So there's some contradictions within relativity that haven't been handled. There's a lot of contradictions, actually. And so he was like Lavoisier, who actually objectified heat. Now, what is heat? Do you know what heat is?
It's the movement of
right. It's a movement. See, all phenomena are either matter or motion. Matter I can put in my back pocket. Like I could put a frog in my back pocket. But I can't put running into my back pocket because it's motion. Okay, so Lavoisier said that he invented the caloric theory of heat. And heat was a caloric fluid. that flowed. It was a thing. See, so this is what normally we tend to objectify things. It's like, for example, the primitives sitting around the campfire would be watching the leaves move and so on. What moved those leaves? They don't know about nitrogen and oxygen, about air, having molecules in it. So they say it's spirits. So what they have done is they have objectified this motion. And that's what Lavoisier did. He objectified heat.
Do you think there's a possibility that there were spirits moving the leaves?
It was air, and the air was moving because of different pressure differences.
Yeah, all right. You make a distinction, I think, between deductive reasoning and where you deduce and where you basically observe from nature.
Yeah. See, remember that's also unienvironmental. Deductive reasoning is microcosmic because you have gathered your information and now you're going to sit down and you work on that. And inductive reasoning is macrocosmic.
Right.
So if I want to solve a problem and I've worked all the deductions out and still don't have the solution, what do? I have to have an idea. Ideas are easy to get. How do I do it? I go off to the library. I go on the internet. I pick up some information from somewhere else. That's inductive. I've gone outside of the little box that I'm in. I bring that back, and then maybe that'll work and maybe it won't. But it sometimes works because...
But hopefully this piece that you brought back is based on some grounded piece of knowledge that is proven.
Yes. Yeah, I discard things that don't make sense to me. Of course, they have to fit my little box in a way. Right. This is why I can't see everything. Other people might be able to see stuff that I can't see because of the limitations of what I have, my background.
Is it correct to distinguish inductive and deductive reasoning as one being, when you think of string theory as models, built on models, mm-hmm. or it has been derogatively described as that, and that being deductive reasoning, and inductive logic being more observation-based, built on things that you can observe in the physical universe?
Right. And that's why they don't get out of the office enough, so then they do 13 dimensions. I mean, it happens all the time among mathematicians. And, my co-author's a mathematician. He's just great at being able to make sense of it. And he's not by any means one of these guys that stays in the office. So, yeah, that's true. And see, if you use the assumption that I do, that the universe consists of matter. And what we call matter is an XYZ portion of the universe. That is 3 dimensions. And it has location with respect to other things or other matter. That's what matter is. And then...
And it always breaks down into smaller matter.
Right. So matter
but never into waves.
Right. Never into waves.
The thing they do with waves is to make sense. It's really a model. They're trying to unify quantum theory with relativity.
But you know why? You know why they're doing that? Remember, Einstein has no ether. But they find wave phenomena. There is an ether, and that's why we have the waves.
Is that what brought you to ether? Is that how did you come to ether as?
Well, I think it's once I used infinity as the assumption, then everything is subdividable. Even our ethers have subdivisions. That's all part of the requirement.
Can you, for laymen, can you define ether?
Okay, ether is the immeasurable part of the intervening spaces, and it's the particles, and they're very tiny. We haven't been able to measure them directly. There's some evidence for it, but nothing that says here I've got a package of ether or anything like that. So the ether is what makes matter, and one of our assumptions is
it's empty. It's not.
It's not, of course, empty. It always contains something.
It sounds empty.
Remember when I define matter, matter always contains matter.
Yeah.
Okay? And that works only if it's infinite. This is why when you take physics and they say, and you ask, what is matter? They'll have a hard time saying, because their assumption is finity. They are trying to do like the folks that are trying to find the Higgs boson. They're trying to say, wow, we're going to find this elementary particle that everything is made up of and that makes matter. They aren't going to find it because they're always using the finity assumption. So if you're into affinity, like Big Bang, you're also going to be into affinity for the elementary particle. In our work, we don't have an elementary particle. There's always subdividable. Just like Aristotle said, it's always subdividable. Smaller and smaller particles. And ether particles are, we have what we call ether particles and then sub-ether particles and sub, sort of like that. And each one makes up their own, in other words, the ether particles are made up of sub-ethers and so on.
Sure.
That's just a logical deduction.
Are you familiar with emergence and the idea of physical structures emerging from various substructures?
Yeah, and I think that's what you see at every turn. And I was just
Would you correlate that to what you're talking about?
Yeah, what I did is...
it's a hot topic in cognitive neuroscience right now.
Oh, yeah, well, of course. It's sort of like the transformation of quantity into quality. So if you get enough of some things together...
They take on all new qualities.
Yeah.
And there could be no mathematical correlates between...
No, you can't just say,
incredible.
I can deduce this. You can't deduce it. It's new.
Right. It's a new phenomenon.
You can't do that.
Yeah, and consciousness is like that.
Yeah.
Right.
Well, we do use one assumption, we call it relativism, and it says that there are any two portions of the universe have similar characteristics, and they have some dissimilar characteristics. Now that's really interesting because that means that you will know something about unseen and immeasurable parts of the universe just by studying the parts you can see.
It's like a holographic universe.
Just like we were saying with deduction.
Yeah.
You can study any topic, any subject whatsoever, and it'll apply to other subjects. And you may even notice that in your own life. And it's because the various portions of the universe have some similarities. They always do.
Well, Dr. Borchardt, we have a couple minutes left. What are the implications for the general public, a sane society? These are far-reaching concerns. How do we bring it down to earth and a little bit for the average viewer and say, well, if you're right and these Einstein's conclusions are incorrect, how are they holding us back?
Well, most of the people think that the universe exploded out of nothing. That's holding us back. That is not a very grand vision at all, I don't think. A lot of other silly things, wave-particle dualism and so on, puzzles that have just bedeviled physics for a long time. Physics has progressed in spite of all that, mostly because you didn't need Einstein for most everything that was done. You could blame it on Einstein if you wanted to, but I've got all kinds of examples. You can read some of it on the website, scientificphilosophy.com. Look at that. You'll see one on, like I said, Einstein's most important philosophical error was objectification. And in there, I analyzed the Hafele-Keating experiment, which was this deal where they flew these planes around and with accurate clocks, they went around the Earth, east and west, and voila, they come up with the idea that Einstein is proven correct. I look at the data, I say, what? Look at this data. It doesn't prove anything at all, but that's what it says. And all physics students now still have that idea. So we're misled. We got a long ways to go.
So we have broad areas of science really sort of locked into a paradigm, and they can't seem to get out of it.
Right, and it's not the scientific worldview. Much of it is indeterministic, follows some hope for assumptions that people have made over the centuries. Sorry that they probably won't work in the future.
I see. Well, Dr. Borchardt, thank you so much for coming here and talking to us about this, and hope you'll come back and tell us about your next book.
Thanks so much.
All right. And thank you for watching. Good night.